Now we have to prove that everything I've told you about contraposition is actually true. And we'll do it by starting with an A claim. All cats are felines. And we'll apply the rule of contraposition, the two steps of contraposition to that statement to create this new statement. All non-felines are non-cats. And if what I've told you about contraposition is true, these two statements should express the exact same information and therefore have the same truth values. So we're going to test this by, or prove this by, creating a Venn diagram for our original statement, all cats are felines, and that's going to require us to shade out area 1, because area 1 is an area of the cat building where there could be cats, but we're trying to show that no, all the cats are felines, and if they were in area 1, they wouldn't be felines. So we've got to turn out the lights because there's nothing there. All the cats are right here in area 2. Now, because contraposition involves term complements, we've got to locate where all of the term complements would be. Where are all the non-felines and where are all the non-cats? Well, we know that one place where non-cats would be is out here in Area 4. Think of Area 4 as the rest of the world outside of the building that contains all the cats and the building that contains all the felines. And then outside of those buildings is everything that's not a cat. Okay, so non-cats are out here roaming around in the world that's designated as Area 4. There's also going to be non-cats in Area 3, right? Because if all the cats are enclosed in our red building here, and they're all in Area 2, then anything here in Area 3 would, by definition, be a non-cat. And all the non-felines would also be out here roaming around in the world. So everything that's a pencil, a caterpillar, a person, those things are non-cats and they're non-felines, and they're roaming around outside these two buildings right here. Okay, so now that we've located all of our term complements, we have to ask ourselves, do I see the statement, all non-felines are non-cats, reflected in this diagram? And the answer is yeah, right? Because if all the non-cats and non-felines are out here in Area 4, and everything that's a non-feline is a non-cat, then all non-felines are non-cats, right? So anything, we look out here and we say, hey, check it out, that's a non-feline. Well, they're also non-cats because they're out here sharing territory in Area 4. All right, so that proves that contraposition applies to A claims in the way that we discussed. So now let's see how we can prove that it applies to O claims as well in the way that we discussed. And we'll do that by creating an O claim, some cats are not dogs, and we'll apply the two rules of two steps of contraposition to create the statement, some non-dogs are not non-cats. And we'll diagram in our original statement by marking an X here in Area 1, because that X represents at least one cat that is not included in the dog building, right? So this one cat represents some cats are not dogs. Now what we have to do is locate where all of our term complements are. Can you figure out where they are? Non-cats, again, those are the things out there in Area 4. So we think about Area 4 as representing the world outside of these two buildings, representing cats and dogs, right? So if it's not in the red building, it is a non-cat. And so by definition, it would be out here. There's also non-cats in Area 3. Right? Because Area 3 is also outside of the cat building. So if all the cats are included in the red building, anything in this part of the blue building would be a non-cat. Similarly, anything outside the blue circle is going to, by definition, be a non-dog. The bananas, the caterpillars, the pencils, the people, those are all non-dogs, and so they're not going to be in the dog building. They're going to be out here or tool around in the rest of the world. They're also going to be in Area 1. Because in an Area 1, we're outside of the dog circle. So if all the dogs that exist are included within this blue building here, this blue circle, anything over here in Area 1 would be a non-dog by definition. So we've now located all of our term complements, and we have to look to see, does this diagram reflect the statement, some non-dogs are not non-cats? And this is going to be kind of tricky because we've got the not non working for us here, okay? So let's look and see where the non-dogs are. Some non-dogs are not non-cats. Yeah, this diagram shows that because this X right here, that tells us there's something in Area 1, and that thing in Area 1 is a non-dog and it's a cat. So it's not a non-cat, it's a cat. All right? So this shows that some non-dogs are not non-cats. They're actually cats because they're sharing this space in the cat circle where we know at least one thing is. All right? Hopefully you followed that. It's kind of tricky to think about, but it's also kind of fun to make sense in your own mind of this not non-cat idea. And if you can get that to kind of make sense and understand, like, oh, yeah, I get it. Anything in Area 1 is a cat. And so if there's a non-dog in there, some non-dogs are not non-cats because they're cats. Isn't logic fun? All right, I told you that contraposition does not produce statements that have the same truth value when it's applied to an I statement. So let's see if that's the case. Some cats are fluffy animals, and to represent that statement, we put an X right here. And now what we want to know is, does this diagram also show the statement some unfluffy animals are non-cats, which is the contraposed version of our original statement? So we're going to have to determine that. We're going to have to locate all of our term complements again, right? So the non-cats and the unfluffy animals, of course, they're going to be outside both of our buildings here because they're non-cats, they're unfluffy animals, so they can't be in the fluffy animal circle, they can't be in the cat circle. But non-cats can be in area 3, right? Because area 3 is outside of our red building here. So anything in area 3 would be a non-cat. And anything in area 1 would be an unfluffy animal because the fluffy animals, every single one of them is contained within this blue building here. So now when we look at this diagram, do we see the contraposed statement that we created? Is it really the case that some unfluffy animals are non-cats? And the answer is no. And here's why. And again, this is kind of tricky. Remember that in order to show a some statement, either some are or some are not, we have to have an X. The X represents at least one, or some. So we marked an X in area 2 to show our original statement, some cats are fluffy animals. But if it was the case that some unfluffy animals are non-cats was true, or we were trying to represent that, we'd have to put an X out here where all the non-cats and unfluffy animals are. But there's no X there. And it's because there's no X there, we don't get to say some unfluffy animals are non-cats. We don't know if there's anything actually out here in area 4 that pertains to non-cats and unfluffy animals. Okay? So these two statements don't have the same meaning. This diagram, I can be certain that some cats are fluffy animals because I see this X right here in the common area between my cats and my fluffy animal circle. But I don't know if there's some unfluffy animals that are non-cats out here because I don't see an X. Okay? Now let's look at an E statement and what happens when we apply contraposition to it. So no cats or dogs. We create our Venn diagram by shading in that common area, turn out the lights in area 2 because there is nothing there. We're trying to show that no cats or dogs. Now we want to know, okay, does it also show that no non-dogs or non-cats? To determine that, we've got to get our term complements located. Okay, so everything in area 1 is a cat, but it's also a non-dog because it's outside the blue building. Everything in area 3 is a non-cat and a dog. And everything out here in area 4, if there's anything out there at all, would be a non-cat and a non-dog. All right, does this diagram show no non-dogs or non-cats? No. It actually shows the opposite. It shows that all non-dogs are non-cats. Right? Because anything that exists out here would be both a non-dog and a non-cat. So if anything that exists out here is a non-dog and a non-cat, then everything that exists out here is a non-dog and a non-cat. That means that all non-dogs are non-cats. And that is not the statement that we created when we contraposed this E statement. So this shows us that when we contrapose E statements, we don't get equivalent statements. Okay, we don't get statements that express the same meanings. Therefore, we don't get statements that necessarily have the same truth value. The statement that we get when we contrapose E claims has an undetermined truth value. All right,